Hello. So today we are going to discuss about content delivery network. Previously we had discussed this how this service or orchestration and virtualization been done, abstraction layer and that type 1, type 2 hypervisors. We discussed about hybrid eucalyptus, hybrid between eucalyptus and Amazon EC2. Now today we are going to discuss about content delivery network, or it is also said as content distribution network, CDN. Now the hybrid example we'll see Akamai and Facebook, how Akamai and Facebook do the hybrid. So we- we'll first understand content delivery network. What is that content delivery network? Basically, it says that it is geographically distributed servers, so that there will be a distributed network of distributed servers, so that a proxy server could be there to send the request and respond to the request as quick as possible. So there will be multiple data center being assigned geographically, means one data center could be containing same content in San Francisco and same content it is carrying in London, same content another data center carrying in the Bangalore. So there will be three different uh, servers or data centers which is carrying the same content, but because it is geographically located at three different continents, so the thing is that a response will be fast to the user. How? So the European citizens will get the response from the London based server, and Asia based users will get the content from the Bangalore based server, and America based users will get the response from the San Francisco based server. So it basically divided into three different regions. So the load will be divided into three different regions, and request will be responded quickly for the shorter distance. So this is the purpose of doing all this load balancing. Then it basically, what is the advantage of doing this? The advantage will be high availability, better performance, because distributed systems works efficiently for the end users. Then in it basically came in uh, late 90s, means to improve the performance of bottleneck uh, were there in internet. So there were bottlenecks like only one server is there. So all the users, all the clients are requesting to only one server. But they thought that if we have the distributed server, means there could be two, three different server having the same amount of content, then it would be better. So in 1990s, in late 90s, so this concept of content delivery network came into picture. What is peer-to-peer CDN? There are two type of CDNs: peer-to-peer CDNs and private CDNs. Peer-to-peer CDN says that the consumer provides resources as well as use them. So what does it says? Consumer, basically a company, provides some of the resources and uses uh, some of the CDNs as well. Means first of all they upload something on the CDN, and again they'll start using, accessing it, and processing it. So it's like some peer to peer, means the person, for the person it has been using. So different form of client servers are there in this, means there could be many client and many servers are there working in the peer-to-peer CDNs. So there is a private CDN. So the content owner creates their own content, their own CDNs. So the content owner means like some company like Facebook. Facebook is creating their own CDN, content delivery network. Google is creating their own content delivery network. So that is content owner uh, based CDN. So private CDNs are there. Then there's left and right side of the figure, you can see In this, first one is old way of doing the and simplest way of doing client server model. Means one server is there and five different remotely allocated clients are requesting the to the server. But in the second figure, in the right one, this is CDN scheme of distributed server. So there are basically five different server for the five different zones of clients. So five different zones could be like there are multiple content. So in the multiple content, there could be multiple servers, and each server will provide distributed uh, distributed to the client. Means the particular client of a continent will request to the client of the simple simply for its own continent's server. So what happens, like for an example, good example of private CDN is like expedia.com. Expedia.com is a global website, but Expedia also have expedia.in, means for the India. So you'll have a locally available website of Expedia available in the country India. So this is an example. So in Europe also Expedia.eu is there. So European means, so each country would have their own uh, Expedia website, so that the user who is there, they can access to the local server, as well as there is advantage. For example, so different languages are there for different countries, so that also provides some advantage for developing such website and remotely locating them in nearer to your client. Then Akamai CDN. Akamai is an biggest example of a content delivery network. It is one of the biggest, largest content delivery network company. So it's global CDN, means it is globally located all over the world, and it is basically helping in cyber security. It is a cloud service provider. It is an example of cloud service provider. So the Akamai CDN is one of the largest distributed computing platforms. So means they says that they have installed different data centers and servers and all these infrastructure for networking in various continents and various countries. Basically, CDN is serving between 15 to 30% of all web traffic. Means that's one of the huge traffic. Akamai CDNs are basically operating and renting worldwide networks for server purpose. So what they do, they rent some of the networks and servers across the globe. The consumer website works faster by distributing content from the location nearer to the end user. So what does this say? Akamai people, Akamai engineer do. Akamai engineer basically allocates the website nearer to the clients from where they are requesting, so that it will be little faster to access those pages of that website. So the location would be nearer to the end user. Then end user navigate to the URL of Akamai consumer. What does this say? Uh, so if you are a client or a consumer, so you just call a link. So in Facebook, what happens whenever you call your own photo uploaded on Facebook, so it will come through Akamai CDN some of the times. Why? Because Akamai CDN stores Facebook photos. Then their browsers are being redirected to the one of the Akamai copy of our website. So if some website is being, you create your website, you upload it on Akamai CDNs. So the browser will redirect you to the, means your clients will be redirected to the Akamai copy. Means Akamai website, Akamai CDN would have that copy of your website. Then basically Facebook is one of the consumer of Akamai. So we as a client, means as a end user, uses Facebook, but Facebook itself uses Akamai CDN. And how it is uses, Facebook uses edge server, means server located at various location of Akamai to serve their user faster, so that the photos what we are requesting to the Facebook, it will be faster retrieved to us through Akamai server. So Facebook consumer or Facebook users who have the account will get faster response from the Akamai edge servers. Then this is a simple model for how the user client can request some web server, which is ACME server, and it basically requests to the acme.com. But what happens, ACME server is smaller in size, so it's difficult to means it is that images are heavier in size, so images are being stored in the Akamai server, so images are being delivered from the Akamai own servers. So Akamai deliver this image location on the page, so the image will be called out and this image will be redirected from the Akamai server directly. So what happens if this page is being called out by the acme.com? So this page basically have the index of that image, and that image is being served initially, means at the first time that acme.com will serve this image to the Akamai server, but later on it will redirect to that image. Means image will be coming from the Akamai CDN, so that it would be faster, and Akamai will balance the load balancing and all these things. So then this is another example where this origin is there, means content origin is there, means original website which is storing the data. So it is far from the end users. So the end user, suppose if we'll say this, we'll say this is Hyderabad, this is Bangalore. So these are Indian users. So these are Indian users. They want to use the Hyderabad and Bangalore servers as they are faster to be accessed, but the content is being there in San Francisco. So what Akamai CDN will do? Akamai CDN will transfer the data to the Hyderabad and Bangalore server, and previously means earlier to the request of the end user, it has already been transferred to these servers, and these servers already having copy of the origin content. So the copy of these content will be provided to the end user from Hyderabad and Bangalore servers. So that it would be faster, means this route will not be followed again and again. So for example, this is, you can say, Hyderabad, this is Bangalore, so Bangalore. So it is the route it has to trace only once. So only once it has to come from the origin server. So the copy will be kept in the Hyderabad and Bangalore. So we'll see a specific example that how Akamai and Facebook works together, so that it will be easier for you to understand that how this photo stack of photo serving stack of Facebook works. So we'll see the example of a photo serving stack. This is an example. This is a research paper from where this thing has been collected. An analysis of Facebook photo caching. So it's published in one of the topmost conferences of operating systems. So the Facebook photo serving stack is basically says that components are being linked to show that the photo retrieval uh, workflow. So the components we are going to discuss that how a photo retrieval will be faster. Then the how it works, this Facebook photo serving stack. Facebook photo serving stack with the different work with the different components linked together for serving photo faster, and it makes workflow faster. Now what happens? desktop and mobile client, whatever we know, we are using Facebook from many days. So from desktop or mobile, wherever we request some some photos, so the request goes to the Facebook or the CDN available to the uh, nearer to us. So what happens, which actually routes either directly to the Facebook edge or via Akamai CDN, depending on the fetch path. So what happens when we request the we start using Facebook? So the request goes either to the Facebook edge, which is allocated nearer to us, or via some Akamai CDN, whichever be the nearest or faster to be respond. So this fetch path we'll see. So the fetch path we are going to discuss in the next slide. So this origin cache, what is origin cache? Collects basic traffic from both paths. So origin cache says that this is a origin database, means the original content of all the things that you upload goes to some haystack. Haystack basically contains original information, but this haystack also have some cache which can respond faster to the some content which are heavily used. So some, for example, some of the there's going some FIFA World Cup, Football World Cup, or some Cricket World Cups are going on. So there are few images which are common in nature. So these common nature image or the most popular post or tweets which are popular. So these links are being there, these images are being there in the origin cache. So origin cache basically collects uh, traffic from both the paths, means serving some of the image from the cache and resizing them if needed. So what origin cache do? Origin cache do the load balancing of traffic from both the path, means edge server or Akamai CDN. And basically it serves cache image, means cache image means one which is very heavily used, and then resizing them if needed. So what is resizing them? So resizing them is basically says that uh, there is large image that you had uploaded, but it has to be reduced in size so that it will be faster to be sent to the clients. So this resizing is also being done by the origin cache servers. Then Haystack is the most important back-end server that actually stores everything that is original. So this actual image content has been stored in Haystack, and all these things, Origin Cache or Facebook Edge or Akamai CDN only uses the replications or copy of Haystack. Haystack is the original backend server, and this Origin Cache, Facebook Edge, and Akamai CDN only contains the heavily used images. Then this is the Facebook's photo serving stack. So what does it do? Facebook's photo serving stack, basically, if you are a client, you are using some browser or some app. So first of all, the request will go to the your own browser or cache. If that own browser and cache have the content, then you'll get the response. But if this you you didn't get the response from your client from your own browser, then it says that it will go to the point of presence. What is point of presence? It is edge cache. What is edge cache? So first, browser cache is being searched by the client. Then edge, what is edge? It is point of presence. What is Facebook edge? Facebook edge is nearest set of cache, means that can run inside the point of presence closer to the end user. So edge computing basically deals with something which is very closer to the client. So there's a server in the Hyderabad. So it is nearer from the city of India. So that is this Bangalore server is point of presence, you can say. So this is closer to the Indian end user. Indian clients are closer to this Bangalore server. So any day this will work as a edge of India. So this edge cache is there, means of course this server storing the content in the Bangalore might not have the original content of the some user from US or UK. So this is just containing Facebook server containing this of Bangalore containing a replication. So that is edge caching, and this edge will be requested whether that Bangalore server contains the content or not. So whether that edge server has that content or not. If it is there in point of presence, means at the Bangalore, so it will be returned back to the client. So that is point of presence. Now we'll go to the original data center of Facebook. Means there is a original data center, whether it is located in San Francisco or it is located in some of the original data center may be located in Bangalore or Hyderabad. So there could be multiple places this data center could be located. So what is name of this original data center? It is named as Haystack. So Haystack is the original backend, and that access the first of all it accesses the origin cache. What it does, it requests to the origin cache that whether the content is available in the origin cache or not. So why it requests? Because it is not present in the edge cache. So edge cache miss is there in Bangalore server, it missed out. So it goes to the origin cache of the data center. Suppose it is in the San Francisco. So this origin cache will be requested at the San Francisco. Then it says that yes, it's present. The content is present. So you'll get the as a client you'll get the image. But what if this origin cache don't have that image that you are requesting? So the request further goes to the backend haystack. So the when the origin cache miss happens, so the this is definite that backend haystack will be have a hit. So the original server or original content, all the content was there in the backend haystack. So that backend haystack will serve you back to the client. So it's like this haystack is defined like this. Backend layer accessed when there is a miss in the origin cache. So this origin cache is being missed, then only this client will get the response. So it's like you will get a direct response from here. So it's not like you have to travel all the path again. So if there's a miss, it will go like this only, but it will return you directly. So this is how it usually redirects. Then this image is being retrieved from a local haystack server. So what it does, it creates replication to the origin server because it is one of the used image. And again, if it creates replication to the edge server, edge cache, uh, and this also creates replication to the browser. Automatically this happens. So this is how it works. The image which is oftenly being used by the from the haystack is uh, it's been copied to origin cache, and it's been copied to edge cache as well as to browser cache. So this is the detailed architecture of hybrid Akamai and Facebook server. What is detailed about this? This architecture says full life cycle of a photo, whatever you had stored. Means you had uploaded some photo directly to the server. So what it does basically photo transformation at the server point. So the photo transformation happens. So what it do resizing of and it do resizing and transform the photo that are being requested by the Akamai CDN. So Akamai CDN photos are being modified. So the resizing, first of all, resizing will be done at origin cache. So here you will get the resizing. At Haystack itself, you do the resizing. So the photo transformation is one of the property that origin server do. It do resizing of that photo means it compresses the photo and whichever been requested by the Akamai CDN, so that it will be easier to transfer the photo. Then caching is stack. So it do the cache. What it do? So the client have desktop or mobile. So they search in the local cache of browser. If there's a cache miss over there, then it requests to the point of presence at Facebook ad server. Facebook ad server is being requested. If there is a request means available means there's an image available, so this response will come up. And on parallel of this, your client is also requesting to the Akamai server. So Akamai server is also being requested. Akamai CDN is also being requested. If there is availability of image is there, then again you will get a response from that. So Facebook Edge is also been called out, and Akamai CDN is also been called out, depending on various scenarios. Then, if both the things, Edge server and Akamai server, both have a cache miss. So both have a cache miss. Now the request goes to the third. So it will request to the origin server. The origin server is being requested, where the cache is being called out. If there's availability of that request in the cache of origin server, this server, origin server, is being requested. If it is available, then you'll get this cache will be replicated and the you'll get the cache will be updated of point of presence, as well as Akamai server will also be updated, and you'll get the response back from here. So this is how the point of presence is also been updated. Then if everything fails out, means this everything means origin cache also have a miss, means the origin server do not contain the image, means that origin server do not has that content of image. Then the storage server, this storage server, original storage server, means original size it has, original content it has, it will be requested, and that is set to be backend haystack. Backend haystack. So what it does, it replicates that same image with some resizing to the origin cache, and it also replicates the same image to the point of presence cache, and then it returns all that image, means respond that image to the client. So basically what happens, the replication happens this way. So replication copy happens this way, but as a client will get direct response from the data centers, so that the response will be faster. So it's not that it will follow this path of after copying all these things you'll get the so it's not this path. So this is what it means by all this CDN Akamai. So I hope that you have understood that how cache hit and cache miss works in the Facebook Akamai CDN system. This is the whole concept of Facebook photo serving stack. And I hope that you have understood Haystack, Origin cache, Facebook Edge, and Akamai content delivery network to serve a client over here. So the client would be served out. So this client would be served out by the Facebook Edge or Akamai CDN if they have the content. If the content has been missed out, then Origin server will be responding to the client. Then otherwise, if Origin server also have a miss, then Haystack backend will start doing the response. Yes. Then in the next class, we'll discuss about platform as a service and container as a service. Google App Engine will discuss and it will compare it with the Docker Hub. So I hope there would be you had enjoyed this session and we'll meet in the next class. Thanks. Bye.